In this lecture, let's create our first state. The initial state of all enemies should be to return to their original position. If they're in their original position, they will keep an eye out for intruders. Let's get started. In the scripts/character folder, create a new C# file called AI return state. Next, open this file. Once again, clear the contents of this file. The goal is to write a class that inherits the abstract base class. Before we start writing the class, let's add the rpg.character namespace. Next, add a class called AI return state. The most important step is to inherit the base state. After the name of the class, add a colon character followed by the name of the class, which is called AI base state. Almost immediately, an error gets thrown. According to the error, the class is missing two methods called enterState and updateState. Without these methods, we have an incorrect implementation of our state. Let's add both methods. Keep in mind, the methods should be public since the abstract class defines them as public methods. In addition, we must add the override keyword after the public keywords. Lastly, the parameters are missing from both methods. We must accept the enemy controller class. Let's set the name to enemy. Congrats! You've created your first state. These steps will be repeated for each state. To verify our state works, let's log a message to the console. In the enterState method, call the debug.log method with the following message, entering return state. We may get an error. The error stems from the debug class not being available from this file. This is easy to fix. At the top of the file, add the Unity Engine namespace. Great! The next step is to initialize this state from the enemy controller class. Open this file in your editor. At the moment, we don't have access to our state. Our state classes are not instantiated by Unity. Since they don't inherit from the monoBehavior class, Unity will not allow us to add them as components. Therefore, we must manually create instances of each state. Below the variables, create a private variable called currentState. The type for this variable will be the AI base state class. The first step is to keep track of the current state. The state pattern dictates that only one state can be active. The active state will be stored in this variable. If we want to switch to a different state, we must update this variable. Most importantly, we're setting the type to the abstract class. By using the abstract class as the type, we're guaranteed that all states have the enterState and updateState methods. Next, let's create another variable called returnState. This time, the variable will be public. As for the type, it'll be set to AI return state. Lastly, set the value of this variable to the following, new AI return state. You may be wondering, why is the variable public? We should allow our state classes to switch between different states. Before switching to a different state, we must have access to the state. Otherwise, switching between states may be difficult. We're almost finished. The next few steps are to set the current state variable to the return state variable. After setting the state, we can start the state in their respective locations. Let's set the default state from the awake method. At the top of the method, set the current state variable to the return state variable. The last step is to invoke the methods from the current state. Below the awake method, define a method called start. I'm introducing a new method from Unity. This method is another lifecycle method. It's similar to the awake and update methods. Similar to the awake method, the start method is called once. The main difference between both methods is that the awake method gets called after an object has been created, whereas the start method gets called when a component is enabled. The awake method will always be called first. As for the start method, it's not always guaranteed to run. If a component is disabled, this method will not be called. The question is, why are we using the start method? It's completely possible to stick with the awake method. However, from my experience, I prefer to use the awake method to create variables. The start method is great for performing logic. Of course, not every Unity developer follows this practice. There are developers who stick with the start method for everything. At the end of the day, it's completely up to you. Within the start method, call the currentState.enterState method. We're starting the state by calling this method. As a reminder, the enterState method should prepare the state by initializing variables. The enterState method accepts the instance of the enemy controller class. However, we're already in the enemy controller class. How do we pass on the current instance to another class? That's simple. We can use the this keyword. The this keyword represents the current instance. By default, Unity creates an instance of a class when it's added to the component. This instance is the value for the this keyword. Through this keyword, we can access the variables and methods from within the same class. For example, if we want to access the chaseRange variable, we can write this.chaseRange. This snippet of code is the same as writing the variable name. Typically, we don't have to use the this keyword to access variables. C# was designed to allow developers to grab variables by their names. The this keyword was introduced to allow us to pass on the instance to other classes. One more step before testing our code. The updateState method should be called. Currently, the returnState does not have a body for the update method. That's perfectly fine. We're going to add a body in a future lecture. Inside the update method, call the updateState method with the this keyword. Essentially, we're outsourcing the logic for updating the object to the current state. We're finished. Let's save our changes and test our code. Head on over to Unity. Try playing the game. In the console, the return state has been entered. That's exactly what we wanted. It took a while, but we finally have a default state. Whatever the current state is, the enemy controller will handle calling the current state's methods to affect the game object. We've established a connection between the game object and state. As the course progresses, it'll become clear why having a state is helpful. The enemy is going to have a lot of logic. Splitting the logic into states will make our code manageable. In the next lecture, let's work on the return state to return the enemy to its original location.